Math 76, Lesson 45, writing decimal numbers in expanded notation and other forms of multiplication. So, we've done expanded notation with whole numbers, now we're going to do it with decimal numbers. And if you remember, the key to doing expanded notation in whole numbers was knowing place value. So remember that the 4 has a place value of ones, right? The 0 has a place value of tenths, the 2 has a place value of hundredths, and the 5 has a place value of thousandths, right? And the 4 should be pretty easy. So for the 4, all we have to do is create a set of parentheses, put 4, multiply it by the number 1, and parentheses. And then we're going to add the next place value. Now the next place value, thankfully, has a 0 in it, so we don't have to deal with the decimals yet. So remember, any place value that has a 0, we can skip. So now we go on to the next one, which is 2. So we're going to set our parentheses, we'll put the number 2, and then we're going to multiply. And now the question is, what do we multiply it by? How do we make 2 meet hundredths? Well, it's very simple. We're just going to use the fraction for that place value, hundredths. So 2 times 1 100ths. So if you remember, if we just had this number is read as 2 hundredths. 2 times 1 100ths would give us 2 hundredths. So we use the fraction form of that place value. Next, we go to 5 thousandths. So we put our plus sign, 5 times 1 over 1,000, or 1 1,000ths. That would be 5 thousandths. And that's how we turn decimal numbers into expanded notation. So same logic, we just have to understand how to write these decimal place values. This one would be 1/10, this one would be 1 100th, this 1 1,000ths. And if you've been reading your numbers correctly, this shouldn't be a hard thing to change in your brain. So that's how we take decimals to expanded. How do we take decimal expanded notation into decimal numbers? So let's do the inverse, or the opposite. So let's take this number. Okay, so now we've got 2 times 10 plus 4 times 1/10 plus 5 times 1,000. So let's just take these numbers and write them. So 2 times 10 means I'm going to have a 20. Now I don't see any ones place, so that means there's no value in the ones place, so I can go ahead and put a 0. Now I'm in the tenths place, so that means I'm into decimals. So I have to add my decimal point, and then I can put the number 4 in the tenths place. Now we notice we skipped the hundredths place, so we go from tenths to 1,000, so the hundredths place must have a 0 in it. Then for 5 in the thousandths place, we're in the thousandths place, so we just put 5. So this number is 20 and 405 thousandths. Final answer. So pretty simple once we understand how to read the symbols for these different place values. Now let's go to other forms of multiplication. Other forms of multiplication is really simple. It's just different ways to write a multiplication problem. Let's see here. Normally we've been using symbols like this. Maybe I'll put them in a column right here. We've been doing 3 times 5 equals 15. And this is the main symbol that we've been using for multiplication, is this x, right? But there are other symbols that we also use. For example, we could also use 3.5, right? That dot is the exact same thing as the x. It means multiply. So if you ever see 3.5, that means 3 times 5, which gives us 15. Another way we can do it is with parentheses. So when we have parentheses and 2 sets of parentheses are touching, or a number is touching a set of parentheses, that means multiply. So the first form would be parentheses 3, parentheses 5. These 2 parentheses are touching with no symbol in between them. That means they must be multiplied. So that is going to equal 15 as well. And now, the other way a set of parentheses can work is if a number is touching the outside of a set of parentheses, it's also multiplied. So I could just have 3 parentheses 5. That also means multiply. Or I could also have the inverse. We'll move this 3 in parentheses and then 5 on the outside. That could also mean multiply. So all of these equal 15. And these are just different ways of writing the multiplication symbol. And then the last way, which is one way that you should have already seen in your problems, especially with your unknown number problems, is if we have 2 letters touching, like R times T, that would mean R times T, right? Or if we had 5 r. That means 5 times r. Let's say 5r equals 20. That should look very familiar. Then we would just have to divide, and we'd figure out that the missing number is 4. So if you have letters involved, if a letter is touching a number or a letter is touching another letter, that means multiplication. If it's numbers, we have the x, we have the dot, and then we also have the use of parentheses. Let me see here. Yeah, that's it for this lesson. So, oh, okay. No, wait. Hold on. Oh, okay. Then the other one is the commutative property of multiplication. I forgot, that's not it for this lesson. We have one last thing. So the commutative property of multiplication lets us know that any number times, that when you have a group of numbers being multiplied, it doesn't matter what order they're multiplied in. Perfect example that I can give you, I'm going to go ahead and turn my paper sideways. Perfect example I can give you is 1 times 2 times 3. That equals, let's see here, 1 times 2 is 2, 2 times 3 is 6. Right? And then what if we switch those numbers around? What if we took them backwards? We did 3 times 2 times 1. That would equal 6 as well. And then what if we completely scrambled them? What if we did 2 times 1 times 3? 2 times 1 is 2, 2 times 3 is 6. So, and there's still a couple more ways that I can rearrange these. It doesn't matter what order you put numbers in. If they're all multiplying, you will always get the same answer. So what that tells us is, or that's called the commutative property. And so if you have multiple numbers being multiplied in the commutative property, like let's say we had a large problem like this, 2 times 5 times 2 times 7 times 2 times 3 times 2 times 3, we could put all of these numbers in order using the commutative property. So sometimes they'll tell you to find the factors of a number and then put them in order to commutative property. That just means they want you to arrange them least to greatest. So what I'm going to do is I'm going to look at all the 2's. I've got 1, 2, 3, 4 2's. So I'm going to put 2 times 2 times 2 times 2, 4 times for each of those 4 2's. Then I find the next biggest number, which is 3. 1, 2. I've got 2 3's, so I'll go ahead and add those down here. And then I've got 5 is the next number, and the last number is 7. So that's putting numbers in order according to the commutative property. And that's very useful in math because that lets you see exactly how many 2's you're dealing with, how many 3's you're dealing with, 5, 7's, etc. So sometimes they'll ask you to find all the factors of a number and then put those factors in order according to the commutative property. That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.